Well, welcome. In this video, we're going to be looking at another type of special case that we would be factoring, and that is going to be when we're dealing with the perfect square trinomial. Now, what is a perfect square trinomial? Well, if it's in this form, a squared plus 2ab plus b squared, it's going to end up factoring to be the quantity a plus b squared. Or if it's a squared minus 2ab plus b squared, that's going to factor to be the quantity of a minus b squared. So if you look at these two, the big difference is that the first one, it's all pluses, and the second one, it's minus and then a plus. Now, how do you determine whether it's a perfect square trinomial? That's a great question. Well, here's how you determine whether or not it's a perfect square trinomial. It has to meet all three of these criteria. First off, are the first and last terms perfect squares? And secondly, if they are perfect squares, then find the values of a and b. You do that by taking the square root of the first and last term. And then you're going to check to see if the middle term is the same as 2 times a times b. So you'd actually take 2 times those values you found in step 2 and figure out if it's the same as the middle term. It seems kind of complicated, but let's look at these examples. You can see that it's really a lot easier than it sounds. So looking at this first example, 16x squared plus 24x plus 9. Now don't forget, you always have to look to see, is there a GCF? Is there a greatest common factor? There is no greatest common factor. And so next I look to see, is it in either of these two forms? And it is. I've got both pluses here. So now I want to see, is this a perfect square trinomial? So what I'm going to do is I'm going to figure out what a would be. A in this case would be the square root of 16x squared, which would end up being 4x. My value for b in this case would be the square root of 9, which is 3. So I am able to take the square root of the first and last terms. So now I want to figure out if it's a perfect square trinomial, and does it meet that last requirement? Is the middle term the same as 2 times a times b? Well, if I take 2 times 4x times 3, well, 2 times 4x is 8x. 8x times 3 is 24x. And sure enough, that's the same as our middle term. So since all of this is true, that means this can be factored. And so it's going to be factored to be a plus b quantity squared. So in this case, a is 4x, b is 3. So this will factor down to be 4x plus 3 quantity squared. Let's look at the next one. Now this next one, we got to be careful because right off the bat, I see something that makes me know it's not a perfect square trinomial. Take a second to look at the form it's in and look at what we have up here as our setup and see if you notice something that would make it so we can't factor this down as far as being a perfect square trinomial. Do you see what it is? Well, there's a problem right there. This is a minus and a minus, and to be a perfect square trinomial, it's either got to be a plus and a plus or a minus and a plus. So this is not factoriable. At least it's not a perfect square trinomial, so we're not going to be able to factor this right now. Okay, I want you guys to work on these next two. So I want you guys to see if you can't factor these down. Remember, you have to look for a greatest common factor first. That has not changed. That is always your first step in factoring. Always look for a greatest common factor. One of these two has a greatest common factor, and I'll just tell you now that both of these can be factored using those forms that we just talked about. So, but one of these has a GCF that you have to look for first. So why don't you pause the video and see if you can't factor these down, and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did here. This first one, number 3, this is the one that I was telling you about. This is the one that's got a greatest common factor. If you look at the 2, the 20, and the 50, all three of those numbers are divisible by 2. So we're going to factor out a GCF here of 2. So when you do that, you end up with x squared minus 10x plus 25. So now I want to see, well, is this x squared minus 10x plus 25, is that a perfect square trinomial? So first I'm going to take the square root of x squared, see if that's possible. Sure enough it is, so my value for a would be x. Now I want to look, is the last term, can I take the square root of that? Well, square root of 25 is 5, so far so good. So now I want to see, is the middle term, now you want to ignore the minus for right now, but you want to see, is the middle term the same as 2 times our value for a and our value for b, so 2 times x and the 5. And sure enough, that gives us 10x, and we see that the 10x is the same as that middle term. So this can be factored to be 2 times the quantity x minus 5 squared. You do not want to forget to include the greatest common factor as part of your answer. That is very important. So hopefully you got that one right. Let's look at the next one. So the next one, the 4x squared minus the 28x plus 49. There is no greatest common factor here, so we skip that part. So now I want to see, is the 4x squared, the minus 28x, and the 49, is that a perfect square trinomial? So to figure that out, first, let's take the square root of 4x squared. Square root of 4x squared is just 2x. So far, so good. Take the square root of 49. Sure enough, that works out to be 7. So now I want to figure out, is 2 times that 2x and times the 7, is that equal to our middle term? Sure enough, 2 times 2x times 7 is 28x, which is our middle term. So now we want to factor this down. Since it's a minus and a plus, again, you want to factor this down to be the a minus b quantity squared. So this will be 2x minus 7 quantity squared. So that is it. That is how we factor a perfect square trinomial. So good luck now as you work on your assignment. And by the way, if you haven't done so already, you want to make sure you watch those previous videos so you do know how to find a greatest common factor and how to factor a difference of two squares.